Oldu, tamam Evren. Tamam, görünüyor şu anda.
Okay. Hello, everyone, for the third day of the 5th Azarquiel School of Astronomy. And today in the evening, we are going to welcome Professor Dr. Yavuz Unat for our History of Science public talks. He will be with us talking about the Muslim astronomers who influenced Copernicus, actually. By the way, welcome everyone who are also watching us on YouTube, also attending on the Zoom channel. Welcome, Professor.
Welcome, everyone.
How are you?
Evet,
İyisiniz inşallah.
teşekkürler, thanks.
We have been late for some technical problems. Sorry about that. So we should get started as soon as possible. And I leave the word to you. Okay, we can see you now.
Yes. My presentation is Muslim astronomers who influenced Copernicus. It was produced within the scope of the project on mechanical interpretation of the universe in medieval Islamic astronomy and its effects on the West. Yes, the 15th century was a period of Renaissance. There is change in the West, in science in the West. The reflection of this change in astronomy was the theory of heliocentric universe, which was put forward by Nicolaus Copernic. This theory was not immediately accepted in the West, but it brought great change in innovation. He used the views of his predecessors to demonstrate heliocentric theory. Among the astronomers Copernicus benefited from were as well Muslim astronomers. Ptolemaios was constructed the theory of geocentric universe as mathematically. Nevertheless, this mathematical theory criticized from the time it was founded. Ptolemaios is an astronomer who performs mathematical adding of the geocentric system. He explained the irregular movements of planets with epicycle and eccentric model. This is the eccentric circle and epicycle model. The eccentric circle model for the motion of the sun. This is the epicycle motion models, concentric different and epicycle models for the motion of the sun. But theory of planets so complex. Ptolemaios' theory of planets so complex. The planet located in H moves on the center. H, the planets, moves on the C center, while the epicycle circle moves over the F centered circle. This is the concentric circle. D is the eccentric circle. EA, shifted center, external center, or E is the center of the equant. The measurements are made according to D, F, and E center, so complex. Yes, the theory, Ptolemaios' theory, mathematically. Nevertheless, this mathematical theory criticized from the time it was founded. Particularly, these criticisms were directed by Aristotelianists and were almost rejected by Aristotelianists because the system did not physically conform to Aristotle's view of the physics universe. In particular, the epicycle eccentric, and equivalent model, a geometric mechanism, designed and used by Ptolemaios for irregularities in planetary motions, were controversial. Yes, were these geometric models, or did they have physical relativities? Mathematical astronomers suggested they were geometric models. According to the Aristotelianists, these were entities that had no physical. Some astronomers, however, preferred the middle ground, accepting these models as physical beings and trying to combine Ptolemaios' mathematical kinematic approach with Aristotle's dynamical approach. But the criticism didn't just come from a physical point of view. The system was also discussed mathematically. These discussions were again on the axis of eccentric, epicycle, and equivalent. Mathematically, the most problematic celestial bodies were Mercury and the Moon. Mercury was twice in orbit, the closest position to Earth, perigee. Again, the Moon was getting closer to the Earth in the locations of the quarter than any other location. Ptolemaios was able to solve these facts in part, but the solutions was not enough. Thus, three opinions emerged in the field of astronomy, especially in the Middle Ages, and astronomers went on to adopt one of these three views. First, astronomical assumptions are simple mathematical fiction, and their task is to save appearance or fact. Ptolemaic system also performs this in the best way. Those who accepted the second opinion went on to put another system in front of Ptolemaic system, and accordingly either adopted the system of concentric spheres put forward by Eudoxus and Aristotle, or proposed new systems like the system of concentric spheres, especially by Vitruvius. In the third opinion, this system was conceived as a sphere layers in accordance with the physics of Aristotle, and the eccentric and epicycle models used by Ptolemaios were considered as a concentric object. Ptolemaios' Almagest, in which he discussed the mathematical principle of astronomy and explained the movements of the planets mathematically and geometrically, namely as kinematics, was particularly critically studied by Islamic astronomers and demonstrated his mistakes. As a result, it became clear that there was a need for a new astronomy, and Islamic astronomers created their own models by attempting to establish an alternative model of the universe against Ptolemaios' astronomy. Ptolemaios' authority was shaken, and Aristotle's cosmology began to crack with new theoretical attempts that began with Nasiruddin al-Tusi and continued with other Muslim astronomers. These new theoretical attempts represent a solid transition between Ptolemaios' theoretical system and Copernicus' theoretical system. In context, many Muslims opposed the astronomers' Ptolemaios' explanation. Some suggested new models of Mercury and the Moon. Others tried to create new models. Among these, three important additional hypotheses or models were popular among Islamic astronomers. The first, Haysam's hypothesis or Al-Hazen's hypothesis. Al-Hazen or Hayzam accepted this hypothesis, criticizing the eccentric, epicycle, and equivalent models of Ptolemaios, and proposing the establishment of the new system without them. This hypothesis, that is, each circle only makes uniform motion around its center, in the doubt on Ptolemaios. Alhazen accepted this hypothesis, criticizing the eccentric, epicycle, and equivalent models of the Ptolemaios. Because he is an Aristotelian, the Earth should be in the center, but Ptolemaios system not in the center. The Earth not in the center, is in the center. The second hypothesis, 2C couple. 2C, 2C was a well-published author writing on subjects, math, engineering, prose, and mysticism. In astronomy, 2C created very accurate tables and planetary motion and updated planetary model and critiques of Ptolemaic astronomy. In the astronomy resolution, Al-Tazkire fil ilmil heye, 2C use this model. Using this model, which is called by its own name, 2C proposed new but quite complex hypothesis for the Moon and Mercury. Copernicus also used it. This is the 2C couple, which converts circular motion to linear motion. Point C moves over the GD line, the diameter of the large circle, with the movements of the small circle inside in the opposite direction relative to the large circle. The model used by Copernicus to convert circular motion into the linear motion. This is the Copernicus book. The other hypothesis is Urdi's hypothesis. Urdi worked as an engineer and teacher of geometry and built instruments for Malik Mansur of hymns. In Meraga, works in Meraga. 2C, Urdi's hypothesis, that is, let us draw two lines on the straight line AB, equal angle A equal B, equal length AC equal AD, and the same direction line CD, and occurs when the end of these two lines are joined is parallel to the first line AB. Urdi also used this hypothesis to develop Moon and Mercury theories in the book of the Astronomy. These three hypotheses have become very popular among Islamic astronomers, and many astronomers have tried to explain some unexplained planetary phenomena and Ptolemaic astronomy by using this hypothesis, again by accepting the Earth as a center. Some astronomers have tried to construct completely different models of universe. The most famous among them, Vitruvi. Alpetragius in Latin. Alpetragius or Vitruvi was the first astronomer to present a non-Ptolemaic astronomical system as an alternative to Ptolemaios models, with the planets born by geocentric spheres. Another original aspect of his system was that he proposed a physical cause of celestial motions. His alternative system spread through most of the Europe during the 13th century. He criticized Ptolemy and tried to establish a different system from his system in the book of Astronomy. This is the Vitruvian system, most complex, and the pole of the equator, and the pole of the ecliptic, L, the pole of the spheroplanet, P is the planet, M is circulating at a constant rate around the N pole. This constitutes the tropical movements of the planet. The sphere on which planet P is located is a common central sphere, and the L pole of this sphere travels at a constant rate centering the M pole. This is the complex system. He influenced by his teacher Ibn Tufayl, and Jabir Eflah, both in 12th century. In the Kitab el-Haya, the book of astronomy, Vitruvian criticized the epicycle and eccentric models of Ptolemaios because it did not match the physics of Aristotle and proposed a new system. Thus, Vitruvian established the spiral motion theory, movement al-Levlavi, and attempted to explain the irregular movements of the planets by return to the theory of concentric spheres based on Aristotle physics. The Kitab el-Haya was translated into Latin by Michael Scott in 1217, and Moses in Thibon in 1259. In the 13th century, Grosseteste, Albertus Magnus, and Roger Bacon were wounded by this work in their research. Another one, in the 15th century, the works of Ali Kushi also affected both the East and the West. In his article, Risala fi hal el-Eshkal el-Mu'addil lil-Mesil, the Risale or Makalat on the solution of the equivalent problem, Kushchi criticized Ptolemaios' Mercury model, and unlike Ptolemaios used a circle that move around their centers at regular speed. In his article, Fi Asl el-Haric Yumkinu Fi Asl el-Sufliyan, the Risala or Makalat on the use of the outer planets for two inner planets as it's for others. He gives evidence that eccentrics can be used in place of epicycles on planets. The same claim is made in Copernicus. In Kushchi's Al-Fatiha, the issues of the sun's relevance of the planets, also used by Copernicus and put forward by Regiomontanus, is much earlier than Regiomontanus' books. The summary of Almagest. It's probable because Cauchy influenced Copernicus indirectly, because it's known that Copernicus has taken such arguments from Regiomontanus. The three additional hypotheses mentioned about and the work of Cauchy were very popular in Islamic astronomy and were used by many astronomers to explain planetary movements. Vitruvian's works mostly influenced Western astronomers. However, the moon's movements were important among the planets, and some astronomers produced new lunar models. The most famous of these is the model of Ibn al-Shatir. He was an astronomer, mathematician, and engineering. He worked as a timekeeper, Umayyad Mosque in Damascus. In his works, Nihayat al-Sul, the recent research, and Talik el-Ersat, the speech on observations, he discusses the regular movements of the planets, Mercury and the Moon, and Sun, and suggests new models to explain them. In this double epicycle system, Shatir placed the Moon on a second epicycle. These models of 2C couple and Shatir's double epicycle system were also used by Copernicus, but their names or books were not references. This is the Shatir's lunar theory with double epicycle. The place is O, the center of the universe, and the small epicycle chamber that creates the motion is carried by the large epicycle circle. The center of the small circle, epicycle circle, carrying the large epicycle circle, is on the sphere called the common centered sphere. Copernicus lunar theory is the same. This is this figure, the lunar theory of Ibn Shatir. Finally, Copernicus studied philosophy, astronomy, geography, and astrology at Krakow University. Most of the astronomy courses at Krakow University were followed by works of Islamic astronomers translated into Latin. Among them are important astronomers such as Alfraganus, Sabit ibn Qura, Haytham, and Jabir ibn Eflah. However, the works of Tusi and Shatir do not have Latin. Where did Copernicus get this information? We don't have definitive answer yet. The environment in which Copernicus grew up was the most knowledgeable about astronomy. It is impossible to not have these researchers in their hands. How possible is it that a great astronomer like Copernicus, who is also making a revolution, is not aware of these searches? For some, Copernicus has received help from Arabic speakers, but the Copernicus may not speak Arabic. However, the astronomers next to him were aware of actions of Muslim astronomers, and probably Copernicus should have accessed this information in this way. Copernicus' technical results have been revealed by recent research that have previously been handled by Islamic astronomers. Copernicus, by contrast, centered on the sun, while Islamic astronomers centered the earth. However, it seems that while it is not challenging to center the sun, some preliminary steps have been taken by Islamic astronomers to make it feel necessary, and some special models proposed by Islamic astronomers have been used by Copernicus. End of the presentation. My presentation. Thanks. Evet.
Thank you very much, Professor.
Any question?
Let me check both on YouTube, also from the Zoom. First of all, let me arrange this. So now we can see each other. Yeah. Would you like to share something, Kevin?
Yes. This question of how Copernicus learned about astronomy from the Middle East is interesting to me because Copernicus didn't read Arabic, and Nasr ad-Din and Ibn Shatir wasn't translated into Latin. And I found an article by a guy named Robert Morrison, published in the History of Science journal ISIS in 2014. And it's called A Scholarly Intermediary Between the Ottoman Empire and Renaissance Europe. And he talks about a guy who lived in Constantinople and in Crete and in northern Italy, right at the time that Copernicus was studying in Italy. And his name was Moses Galliano. He was a Jewish scholar. And so that's the only one I know of, but he could be the missing link.
Maybe. Do you know anything about it, Professor Yavuz? Moses Galliano adında birisi varmış.
Aha, evet.
İstanbul'da yaşayan, ben hiç duymamıştım.
Evet, yani Osmanlı İmparatorluğu'nda çalıştığını mı yapıyor?
Evet. Ve Girit'te çalışıyormuş.
Hı hı. Yani genellikle bu tür bilgilerin zaten Bizans'tan geçtiği de söyleniyor. Yani Kopernik'e bu tür bilgilerin Bizans kanalıyla da geçtiği söyleniyor. Ama
Yeah, there are also some papers telling that the transfer is made from Byzantine.
A manuscript, a Byzantine manuscript
Yes,
at the time. Yes, and the research dates back to the 60s when they traced that Byzantine manuscript. So, that's another way of looking at it. That's true.
Yeah, Otto Neugebauer found a Greek language manuscript in the Bodleian Library at Oxford, and that's now in the Vatican Library. It's Vaticanus Graecus 211, and it has Nasr ad-Din's a Tusi couple in it, and so they were mystified. You know, here it is in Greek, and how did it get here? So we know a little bit more than we used to.
Yeah, maybe. But I also remember that maybe from one of the talks George Saliba made.
Oh, yes.
He was also talking that Copernicus had some priests who knew Arabic and also translated for him. Is it possible? I didn't read his papers about that, but I remember in one of his talks, he was talking about it, that Copernicus had some people around him who knew Arabic, and he knew that there were books, but he couldn't read, so he got help from those people. But I don't know if it's true or not. Öyle bir şey duydunuz mu hocam? Kopernik'in yanında böyle papazlar varmış, yani Arapça bilen de kitapları onlar.
Evet. Yani bu söyleniyor. Zaten genellikle yanındaki kişilerin Arapça bildiği ve bir şey okumuştum ben. Krakow Üniversitesi'nde verilen derslerin içeriklerine ilişkin bir makale okumuştum. Bu makalede de sanıyorum kaynakçamda olması lazım bu. Bu makalede de aynı şeyleri söylüyor. Bu üniversitede okuyan, ders veren hocaların Arapça bildiğinden ve bu kitapları ellerinde bu kitapların olduğundan söz ediliyor. Bu yolla geçtiği söyleniyor. Ama atıf yapmıyor.
The lecturers in Krakow University back then had those books and they were able to transfer the information maybe.
It would be good to look at the papers of Edward Kennedy, George Saliba, Jamil Ragab. They invested a lot of work along this line. And some of the papers even date back from the 40s at AUB with Kennedy. So it's good resources for the students if they are interested.
Yes, Jamil Rajab, he wrote a lot of good work on this.
And Professor Saliba, which
yes.
Yeah.
But I also see some recent papers that are saying vice versa. I mean, there is no such thing. There is no influence in any of Copernicus' saying, right? Is that so? It's not my field, but yeah. So the recent, those kind of recent papers are also influencing the youngsters.
It's a contested field. There's
no consensus yet.
No.
And Noel Swertlow was an expert on all this, and he had a very intellectual debate that got sort of angry with Jamil Rajab. And since then, Rajab has retired and Noel Swertlow has died, so we won't hear too much more from one of them for sure.
Yeah, but the debate is gonna continue.
The debate will continue, yes.
Yeah, okay. Maybe Professor Yavuz, if you share your slides with us, we'll put them also on the web, and people can take a look at also, just like Professor Nadir did. Our students will look at your references, and they will try to learn more about this debate.
I put a reference with the link in the chat box.
Yeah, I saw that. Moses Galliano. That's also interesting. Thank you for that.
Yeah, Eureka. Owen Gingerich had no idea who this guy was. So, you know, the only time in my whole life in the history of astronomy I taught Owen Gingerich something.
Maybe there's also another professor that we also work with, Professor Teza Lunargun in Istanbul University. She might also know about this Moses Galliano. I'll ask her.
Good.
In Ankara University, Remzi Demir works on history of astronomy. Remzi Demir works on Takiyuddin, Istanbul Observatory, Takiyuddin.
Have you heard of him?
We mentioned him yesterday, Taqiyuddin ibn Ma'ruf, the Damascene astronomer in the Ottoman court. Yeah.
It would have been very different for Turkish astronomy if his observatory was not torn into parts, because since then it has been like a 300 years of delay in astronomy in Ottoman Empire and also in Turkey right now. It was a very pity because back then he was very a leading scientist on his field in the age of Tycho Brahe. Yavuz hocamıza çok teşekkür ediyoruz. Orta Çağ İslam astronomide evrenin mekanik yorumu batıya etkileri projemiz için de bir sunum yapmıştı diye yazmış. One of our panelists, attendees, is thanking also Professor Yavuz Hoca. Okay, let me check YouTube for a few more questions. Maybe we could have time. Anyone from the board?
Any questions? No.
This is a very intense topic, actually. It would be great to have this conversation maybe face-to-face in person.
Yes.
Yeah.
For sure.
YouTube'da da soru yok.
YouTube'dan yok mu soru? Gelmedi.
Şimdi tekrar giriyorum da hocam, ben çıkmıştım soruyu. Sohbette. This is a very intense topic actually. It would be great to have this. Evet hocam. Orada da teşekkürler yağmış. Teşekkür ediyoruz. So thanks a lot Professor Yavuz, Professor Nadir, and Kevin for your contributions in this talk also on this topic. It was very nice having you here with us tonight. And maybe tomorrow evening we'll have another history of science talk about astrolabs from another professor in Istanbul Technical University. Okay, see you then for tomorrow. Until then,
Thanks a lot.
take care.
Bye. Bye.
Bye.
Thanks.
Ciao, ciao.
Ciao.
Ciao.
Teşekkürler Yavuz Hocam.
Good evening.
Ağzınıza sağlık.
Teşekkür ediyorum. Sağ olun.
YouTube'u kapatabiliriz.